doing some more factoring today. Today's factoring, a little bit more involved. So, we're going to factor the following completely. We are going to start with 3x squared minus 13x minus 10. What's the first thing I should always check for in factoring? Greatest common factor first. Biggest thing that divides out of all three of them. Nothing nicely. 1, technically. Not helpful. Then we check if A is a number, if it's quadratic. Because if A is a number other than 1, I cannot do the shortcut. What's A here?
Greater than 1.
What is it?
3.
You are correct that it is greater than 1, but I just wanted the actual number. A is 3 here, because remember, quadratics go ax squared plus bx plus c. So this is where a different form of factoring comes into play. Where's my black pen? Oh no. Greatest. So, when A is greater than 1, or less than 1, anything other than 1, we are going to do what's known as the AC method. Now, here's the nice thing. If you are a person who gets mixed up with having lots of different ways to do things, generally, greatest common factor and the full AC method can take care of the 4 types of factoring that we're doing before we start officially getting into chapter 3. So if you can master greatest common factor and what we're doing today, then the shortcut does not need to be mastered, because this will take care of the shortcut. And another form that I'm showing you today will not have to be mastered. Okay, so AC method. First off, it works with ax squared plus bx plus c. Specifically, where that is, a is not equal to 1. If a is equal to 1, I do the shortcut. If A is equal to 1, I can do the AC method. It's just more tedious. So, if I'm going to do the full AC method, the first thing I'm going to do after I check GCF, that's just an always a first thing. The AC method itself starts with off to the side multiplying the number A times the number C. We already said A was 3. What's C? Negative 10. And I just do it a little bit off to the side. I get negative 30. Step 2 is going to look similar to what we did yesterday. And it's going to look similar because what we did yesterday was a shortcut for what we're doing today. That's why I call it the shortcut, because it's kind of the AC method, but it's got some things chopped up because of how it's going to work. We're going to look for 2 numbers that multiply. To whatever A times C is, not just C this time. So whatever that number is that you found off to the side, and adds to B. So it's still adding to that term in the middle, but it's multiplying to that term that we just got off to the side, that negative 30. If you do not know your multiples well, you can always just start listing 1 times what, 2 times what, 3 times what. If you do not know what multiplied by, for example, 2, you should know what 1 times what gives you 30. But let's say you don't know what times 2 equals 30. You got a calculator for a reason. Start dividing. 30 is 2 times 15. 30 is 3 times 10. 30 is 4 times... Nothing that we care about. It's a decimal. It's 5 times 6. And you can stop as soon as you get to a number. Like in this case, I divide by 6, where that number is bigger than that number. So, 1, 32, 15, 3, 10, 4 was nothing, 5 was 6, 6 was the end of the line. Now, I don't have to write this out every single time, but that's just giving me all of my options. Once you have all of your options of things that multiply to 30, remember, if it's positive or negative that we're actually trying to get. Are we trying to get a positive or a negative 30?
Negative.
Negative 30. The only way to multiply to get negative numbers is? Opposites. One positive, one negative. Now, it needs to add to a negative, which means which number should be the negative one? The little one or the big one in the pair? The bigger one in the pair. Is any of these pairs going to work?
15.
Negative 15, positive 2. Now, when you do the shortcut can, once you find those two numbers, you can go directly to double parentheses and get your answer. That doesn't work when there's a number in front, though. Because you can't just say x plus a number and x plus a number. Because, question for you. If FOIL is the opposite of factoring, distributing is the opposite of factoring. If I always just have x and x here, what's x times x? X squared. Do I want it to simplify down to have an x squared? Or do I want a 3x squared?
3x.
Which means it's not going to work to get to that. I have to go a different way. I have to do a step known as the rewrite step. You're going to rewrite the bx part of the expression as those numbers with the variable. Don't forget the variable that was on there. In this case, x. So, this 3x squared is staying 3x squared. This negative 10 is staying negative 10. That's not the bx part. The bx part is this negative 13x, which is going to become a positive 2 and a negative 15. Both of them x's. Plus 2x minus 15x. Does not matter which one goes first. Which one goes first and which one goes second will just change what the middle steps of your equation look like, but in the end, the answer should be the same.
Is it negative 13?
If you combine those, then you're just going right back to the beginning. So do not combine those terms once you get them. The point of doing the rewrite step is it gets us 4 terms. And 4 terms allows us to do something known as factoring by grouping. Factoring by grouping is this idea that you can break is spelled with an R, Benson. That you can break something like this into 2 halves. If it's only got 3 terms, can you break 3 terms into 2 halves really nicely? No, but can you break 4 terms into 2 halves? Yeah, 2 and 2. But you can break into 2 halves and GCF both of them. Some teachers do parentheses here. I don't, because then it gets mixed up with something else. I just underline each of the halves. My first half is 3x squared plus 2x. My second half is negative 15x minus 10. And I greatest common factor both halves. What is the greatest common factor of 3x squared and 2x?
X.
Just x. And if I pull out the greatest common factor of x out of that half, what am I left with? 3x plus 2. Okay, that's the first half. Now I do the second half. What's the GCF of the second half? 5. But wait on that a little bit. Because one of the things that we want to happen when we do our GCF is we want matching parentheses. If we do not have matching parentheses, either we didn't get a GCF properly, like we were supposed to at this step, or the numbers that we said added to B and multiplied to AC were wrong. If I factor a 5 out of this, what is negative 15x divided by 5? Negative 3x. I want it to match this. Is this negative 3x? No. Can I do a negative 5 instead?
But then it's not the base number.
Yes, it is. Greatest common factors, the negative aspect of it is not the quote-unquote biggest aspect. You pull negatives out. The biggest number, we're just talking about the digit. We're just talking about the 5 being the biggest. The negative aspect, you could pull negatives and positives out. Generally, you don't want to leave things starting with a negative inside parentheses. I get what you're saying. You are right. 5 is bigger than negative 5. Ignore the negative for when I say biggest. If I pull out a negative 5, what is negative 15x divided by negative 5? Positive 3x. That's starting to match. That's a good sign. What is negative 10 divided by negative 5?
Negative 2.
Positive 2. Do my parentheses match perfectly now?
Yes.
If they do not match perfectly, that is a problem. But they do. Okay. Final step.
Foil.
No. First off, this wouldn't be FOIL. There's nothing to FOIL out because it's not set up as a FOIL. It'd be just plain distribute.
Oh, yeah.
But you don't want to distribute, otherwise you're working backwards again. A factored form has the parentheses. Now, the question is, what goes in those parentheses now that I've got this? To know that, we're going to take a step back and talk about distribution a little bit. Because distribution and factoring are opposites. How do I distribute something like this? I don't box, but yes, there's a box option and I just don't do the box method. Wait till we're at least done with this example, please. But then make it pass and yes. Foil it out, distribute it out. A gets multiplied by both C and D. B gets multiplied by both C and D. Would you agree with me then that it's essentially saying A distributed into C plus D and a positive B distributed into C plus D? Is that the same thing? So, would you also agree that this that I have right here looks kind of like the setup I have on paper right now? The double parentheses, one of them comes from those GCFs. The other one matches my parentheses. So, that means for a problem like this one, x minus 5 is 1 of my parentheses. Doesn't matter if it's the first one or the second one. And the other parentheses, 3x plus 2. Does this look somewhat familiar? You've done this form of factoring before too. Felix, now you make me fast. Okay. I'm going to try a couple more examples. (12x squared minus 34x plus 10). When, how should I always start factoring?
You multiply the 12 and 10.
That's how we always start AC method. What's something we should always do first?
What's the greatest common factor?
Greatest common factor. Is there something that divides out of all these? 2. 6x squared minus 17x plus 5 after I factor out that GCF of 2. Now, if you forget to do that at the beginning, 2 things are going to happen. 1, you're going to get bigger numbers that are harder to work with. And 2, at the end, you're not going to have the fully factored form, but I am also going to teach you how to spot it if you forgot it, and how to fix it if you forgot it. In the meantime, we didn't forget it. Okay. After I've done that, I hope I could do the shortcut. Can I? Can I do the shortcut? No? Why not? There's a 6 in front of the x squared. So, I'm doing full AC, which means off to the side I am multiplying A times C. A is 6, C is 5. I happen to get 30 again. Is it always going to be 30? No. 2 things that multiply to 30, but when I add them I get negative 17. It happens to be 2 and 15 again. This time, both of them negative. Again, not always going to be those 2 numbers. I maybe could have chosen a better second example. It's okay, we're going to run with it. Can I go directly to the double parentheses now? I don't know why I grabbed this. I don't actually really want to call on this. Many people quite get it. Can I go directly to something that looks like this? No, I gotta split. I gotta rewrite. Now, when I do this, this is gonna get rewritten. This GCF, I'm just gonna put a little star by it to remind me to go back to it, but I'm gonna ignore it for a while, because if I try to pull that GCF through the entire problem, it tends to get mixed up with other things, and it's just a lot of extra writing, because you have to then all of a sudden write extra parentheses, and we're just gonna come back to it. We're just going to deal with the 6x squared, now minus 2x, minus 15x, plus 5.
Does it matter what side the 2 and the 15 are on?
It does not. In fact, I actually meant to write it on the opposite side, just to display something, but I didn't, and I will display that thing on the whiteboard. Understand, though, if you do write them in the opposite order, that your middle steps of your problem are going to look different than my middle steps. The end should look the same, though. Is it minus or plus? Thank you. Okay. What do I do once I have it in 4 parts? Do the grouping. Break it in the halves. What comes out of the first half here? Not 3. 2x. Leaving me with 3x minus 1. What can come out of the second half? 5. Positive or negative? Why negative? So then the 3x will be positive. 5 divided by 5 is 1, but is it positive or negative 1? Negative. Be careful with your positives and negatives. Now, had I done it in the other order, I would have been able to pull out a 3x. Would have left me with 2x minus 5. What would have been the GCF of the second half?
Nothing, that's just the negative. Oh, negative.
Doing a GCF of 1 or negative 1 can become important in factoring by grouping. 1 is the GCF, you would put the 1. And then you check positive or negative, and yes, it needs to be negative in order to make things match again. But it's really the only time a GCF of 1 is going to make a difference. Now, does this look the exact same as this right now? Similar, but the exact same? No. But the next thing I could do is get my final answer. What goes in one of the sets of parentheses? 2x minus 5. And the other one is going to be 3x minus 1. Would I have gotten the same thing in this version? Yes. Except that's not my final answer. Bring your greatest common factor of everything back. Now, I said I would show you what to do if you forgot it and how to spot it. Had we forgotten it, then I wouldn't have gotten this as an answer. I would have gotten either 6x minus 2 getting multiplied by 2x minus 5, or I would have gotten 3x minus 1 getting multiplied by 4x minus 10. The greatest common factor would all of a sudden show up in the binomials. If you notice that you have a binomial that has a GCF, do you notice both of these divide by 2? Do you notice both of these divide by 2? Then you just take it out. I would say, nope, I'm going to put the 2 here and replace that with 3x minus 1. Or, had it been this one, I still put the 2 way in front and replace it with 2x minus 5. So, if you forget the GCF, you could always do it at the end. It just becomes more tedious because then we would have had to find 2 things that multiply to negative 60 but add to negative 34. Sorry, it wouldn't have been 60, would it have? No, it would have been 120 that we had to find things that multiply to, which could be a pain in the butt. Okay, we are almost done. There's one other key thing that I need to make sure we see. (4x squared minus 9). GCF. 1. Can I use the AC method on this? Why not? There's only 2 terms. Now, to use the AC method, it needs to be quadratic. Is it quadratic? Yep. And the number in front of x squared, generally, I don't want to be a 1. We got that? Now, we generally want 3 terms to it, though. Can I write this with 3 terms? What term am I missing? The regular x. How many regular x's does it have then? Can I do that? Can I then do the AC method? A times c is 4 times negative 9, which is negative 36. And now I'm looking for 2 things that multiply to negative 36 but add to 0. Negative 6, positive 6. The only way that you get things that add to 0 is a positive and negative of the same thing. 4x squared plus 6x minus 6x minus 9. And then I've got my 2 halves. Now I'm just going to quickly kind of go through this because this part, nothing is different. Do you notice anything unique about the answer when it's got the 0? They're practically the same thing. They're not perfect opposites, but one's got a plus and one's got a minus. If only that was like a thing. Oh wait, it is. there's a shortcut that you can use on this one too. You don't have to use the shortcut. You could do the full AC method, but this is what's known as a difference of perfect squares, or difference of squares is often how it's shortened. It works when you have something squared minus something squared as your terms. In other words, if I had a problem like 25x squared minus 1, if I'm thinking, oh, I don't see a regular x, so it might be a difference of squares, I'm asking myself, is this a perfect square? Did something square to get me that entire term? Do you have to square? Can you square something and get 25? 5. Can you square something and get x squared? X. So yeah, this is 5x being squared. Is this a perfect square? Is something squared going to give me a 1? 1. 1 squared is 1. And is it minus? Yes. So that is a difference of squares. And the way that a difference of squares will always factor is it'll turn into something like this. A plus B, A minus B, where A and B are the things that got squared. So in this case, that would be 5x, starting both of them, because that's the A. 1 ends both of them. One of them is a plus sign, and one of them is a minus sign. It's another shortcut. You don't have to do it. You could do the full AC method. Yes, Felix.
Is the shortcut only works for, like, if it has big numbers, or is this works for in general?
The true shortcut that we talked about yesterday,
No, for like today, right now.
the difference of squares,
Yes.
only works if it's in this form of something squared minus something squared.
Okay. All right.
There has to be no regular x term, and both the x squared term and the constant have to be perfect squares. I think you got an extra there.